Kinematics, and our goals are translatory motion, frame of reference, and rest in motion. These are the three basic concepts which we need to learn before we start kinematics. All right. So first, understanding what kinematics is. So kinematics is the branch of physics that deals with the motion of the object. The first very important thing, that it deals with the motion of the object, and the second is it ignores the agent that causes the motion. Very important. It ignores the agent that causes the motion. So we do not focus on agent at all. All we look at is the motion of the object and how is the motion. That's all we look upon in kinematics. So that's what kinematics is. Now, beginning with the first topic, translatory motion. So let us understand what translatory motion is. So, well, if you look at the definition, then it says when a body moves in such a way that the linear distance covered by each particle of the body is same during the motion. The motion is said to be translatory motion. So the translatory motion can be divided in two types. The first is curvilinear and the other is rectilinear motion. Let us understand what are these. So let us assume there's an object. Let's say this, and consider any 3 points, arbitrary 3 points on it, A, B and C, and this object is taken in this manner at some other position. I'll redraw it again like this. Alright, so it is taken at some other position, and these are the 3 points A, B and C. So this is, let's say, position 1, this is position 2. So you see that the path which is taken is not exactly straight. It's not straight at all. So this is called as curvilinear path or curvilinear motion, and it's a part of translatory motion. Now let us look at some other example. You have again these points A, B, C, and let's say this time I'll 1 minute. Okay. Send the, oh sorry, this time it is taken in this manner. All right. And you have the object somewhere over here, the same object. All right. A dash, B dash and C dash, so that we understand that they are the two different positions. This is called as rectilinear motion. Why? Because the object has translated in a straight line. All right. The distance between A and B, and the distance between B and C, and the distance between A and C remains the same all the time. Such a motion is called as rectilinear motion. So this is what translatory motion is. So as I said before, translatory motion can be again of two types, curvilinear or rectilinear. And accordingly, as the path of every constituent particle is similarly curved or straight line path, here it is important that the body does not change its orientation. It's really very important. It doesn't matter how the body is taken, whether it's a curvilinear or it's a rectilinear path, but the orientation of the body does not change at all, and that's really very important. All right, so this is what translatory motion is. Moving forward to frame of reference. Yes, so next is frame of reference. So in kinematics, basically every motion which we look at or every motion which we describe in words is always described using a frame of reference. There's always a point with respect to which all the motions are written, all right, or they are expressed. Such a point is called as frame of reference. So the frame of reference is nothing but basically the observer or origin of the Cartesian plane or in 3D. All right. So frame of reference is nothing but the observer or the origin of the Cartesian plane. So all the motion which we write are all with respect to this point. Let's say point A. So in particle kinematics, we assess the position, displacement, velocity, and acceleration of the particle. So for this, an observer is taken as the reference point. Generally, the observer is considered to be at the origin of the coordinate system, while the place where the observer is placed is known as the frame of reference. So, description of the state of a body requires a location of an observer, with respect to which the state must be specified. Otherwise, it would have no sense. I hope it's clear. So, point of reference is nothing. Let's say your observer at point A. When I say a car, when I say a car is moving, sorry for the bad drawing. When I say a car is moving at a speed of 10 meters per second, this is meaningless. It is meaningless unless we mention the frame of reference. So this car is moving at a speed of 10 meters per second with respect to the observer sitting at point A. When I just say it is moving at 10 meters per second, it's meaningless. So it's really important to mention the frame of reference, which is the observer at point A in this case. This was an example. So we can again consider one more example. The example is all right. Okay, so let's say this is a train. All right, this is a train, and there's a box kept over it. Box, and the train is moving in this direction. Let's add a certain speed, v meters per second. There's a guy standing on the train and also moving with the speed of v meters per second because the guy is on the train. There's one more guy standing on the ground at rest. All right. So I'll name them. Let's say this is A and this is B. So, and the box over here. And if you see now, so we observe that like the man at point B, which is at rest, would observe the train is going at a speed of v meters per second. A along with the train is going at v meters per second, as well as the box along with the train is going at v meters per second, right? So for this man A and box and the train are going with the speed of v meters per second. But on the other hand, if we assume this man to be frame of reference, for this the box is moving at 0 meters per second because both of them are moving at a speed of v meters per second on the train. Similarly, for man A, the train is moving at 0 meters per second because he himself is on the train. So for him, the train is moving at 0 meters per second, very similar to the box. So you see that for both of them, both are correct at their place, but both of them see things differently. So that's why it's really important to understand what frame of reference is. So when we solve problem, it's really important to mention the frame of reference so that the problem can be solved easily. Now, let's look at rest and motion. What is rest and motion? So when an object, let's say first of all, and while using these terms, it is really important to mention frame of reference. Let's see how. Again, if I say there's a box over here on ground, so there's a box and there's a guy over here name A. So for this man, the box is at rest. Why is the box at rest? When we say things are at rest, we say the things are at rest when there is no relative motion between the observer or the frame of reference and that object. So for A, the box has no motion or rest. No motion is equivalent to rest. For A, the box has no motion or simply rest, is at rest. And thus we say the box is rest with respect to A. But then if there's another man B who is running at a speed of v meters per second, for him as frame of reference, the man B would see the box moving this way at speed of v meters per second. Very important. For man A, the box is at 0 meters per second or simply at rest. But then for man B, box appears to move at v meters per second in opposite direction. So again, this time as well, both are correct at their place. Both are correct at their place. There's no problem. So because of this ambiguity, we say there exists no absolute rest or absolute motion. So from this we infer that there exists no absolute rest or absolute motion, because the same box was at rest for man A, but then the same box was not at rest for man B. So from this we understand that there exists no absolute rest or absolute motion. I think this should be clear to you. So in definition, we say a body is said to be at rest when it does not change its position with time, while it is said to be in motion if it changes its position continuously with time. So time is taken as the reference unit in this case. So I guess it's clear. And then yeah, here's where I end the lecture, and we'll look at the further topics. So our further topics would be trajectory. We'll understand what's trajectory. Next, we'll understand about its equation of the trajectory. And then we'll start with displacement or distance, then velocity and speed. Well, I should write displacement and distance because both are different things. We'll understand that later. And then acceleration. All right, I hope the things are clear, and that's how we end our lecture today. Thank you very much. Bye bye.